of a student, assume that it is a uniform meter rule, so its weight is acting at the center, and this weight will try to cause an anti-clockwise moment, the turning effect. This is a pivot, and he place a counterweight which try to cause a clockwise moment. So if the two moments are equal or balanced, the clockwise and anti-clockwise, so there is no resultant moment, or the meter rule will remain horizontal. This is a concept student is using to determine the weight of this meter rule. A student places the meter rule on the pivot. He places a load which is labeled 1.5 on the meter rule at 90 centimeter mark, and in a table he record the distance from the distance A from 50 centimeter, like 50 centimeter, that is to the pivot is A, and then calculate and record the table in the table 1.1 the distance B. So how we can determine the distance B? And then calculate and record in the table 1.1 distance B between the center of the load and the pivot. So how we can determine this? Look, what is the total distance between A and the total distance from starting, like the weight, the 50 centimeter mark and the 90 centimeter mark? The total distance is 40 because it's starting from 50 and ending at 90. So the total distance is 40 centimeters. If the total distance is 40 centimeter and A in the first part A is 23.1. So out of 40, if this is 23.1, then how much is B? The B will be 40 minus 23.1. So which is equals to 16.9. It may not appear according to figure. It looks like A is a shorter distance and B is a longer distance. But because student is repeating the procedure, changing it. So if A is 23.1 and the total distance from A to B is like from center of the mass of a meter rule to the center of mass of an object is 40. So remaining distance will be 16.9. So here the value of the B should be 16.9. And then we take a ratio between A over B, A divided by B. So 23.1 divided by 16.9. This will give us 1.37. So 1.37 is a ratio. And student repeat the procedure with different loads. As you can see, 1.5, 1.2, 1.8, 0.5. And he's getting a different results. Plot a graph of a weight or load P on y-axis and the ratio A over B on axis. You do not need to begin your axis at the origin. So we don't have to start from origin. We don't have to start from origin. We can start with any number. This value was 1.37. So the minimum, to know the minimum value is 0.4. A over B, the minimum value is 0.4 and maximum value is 1.37, about 1.4. And for load, the minimum value is 0.5 and the maximum value is 1.5. So we can start, and they already mentioned for these type of question, if they say we don't have to start, and here the next part, as I mentioned, they ask determine the gradient of the graph. So when they ask for gradient of a graph, it means you have to draw a straight line or a best fit straight line. So AB load is on y-axis, the load P is on y-axis, and A over B is on x-axis. So we have load, the P, the unit is N, And A over B does not have any unit. That's why we are not writing anything. The minimum value of a load is 0.5 and the maximum value of the load is 1.5. This is the variation. And we don't have to start from origin. So if I say this is 0.5, 0.6, 7, 8, 9, and 1, it won't be. So if it is 0.4, 0.4, 0.6, 0.8, 1, 1.2, and 1.4, it won't be. So if I start with 0.5 first, like I said, this is 0.5, then 0.7, then 0.9, and 1.1, 1.3, and 1.5. So I have these values from 0.5 to 1.5. And then for A over B, what are the values for A over B? 1.37, the minimum is 0.4 and the maximum is 1.4. 1.37 about 1.4. So if I start 0.4, 5, 6, 7, 8, 9, I won't get 1 point. So 0.4, 0.6, 8, 1, 1.2, and 1.4. So I can get, so this will be 0.6, 0.8, 1.0, 1.2, and 1.4. So first we select the scale. As I mentioned, try to extend your scale. Try to use more than 70% of your graph paper. So after having the scale, now we check the values. When 1.5, this is 1.37. So 1.5, 1.37. So each box is representing 0.02. So this will be 1.224628 and 1.3. This will be 1.3 and we need 1.37. So the 1.37 will be, this is 1.36 and 1.37 will be between. So this is the first point. Then the second point is 1.2 and 1.13. So 1.2 and 1.13. Here we'll have 1.1. Each box is representing 0.02 here. So 1.12, 1.146, 1.18, and 1.2. So this is 1.2. So we were having 1.2 and 1.13. 1.2 on y-axis and 1.13. So this is 1.02. This will be 1.13 is there. So this will be 1.1. This is 1.1 and 1.1, 1.13, 1.12. The first box is 1.12 and the second box is 1.14. So after, like this is 1.2 on y-axis and 1.3. So this is 1.12 and this is 1.3. So this is the second line. Then the third line, the third point is 1 and 0.9. So 1 and 0.9. So when the weight is 1, this one is 0.9. One and 0.9, and after that we have 0.8 and 0.72. So 0.8, 0.8 will be this one, and 0.72. So 0.7, and after that one box 0.72. So 0.72. And the last one is 0.5 and 0.45. So 0.5 and 0.42, 0.44, 0.46, so 0.45 will be somewhat here. So these are the points which we have. Now what we have to do, we have to draw a straight line, best fit straight line. Why? Because the next part is finding the gradient. So we will draw a best fit straight line, try to join these points, or for a best fit straight line, the number of the points above and below should be same. So as you can see, I drew a best fit straight line, like here, 1 point, this point is up, this point is up. This point is down, this point is also down. So 2 points up, 2 points down. So this one is the best fit straight line. And after that, we have to find the gradient. So what is the gradient? The gradient is y2 minus y1 over x2 minus x1. Whenever you're finding the gradient, try to take like maximum 5 centimeter distance between the 2 points you are using it for gradient. So example, if you select any 2 points, you can select, it's not necessary you select the same points which you plot the graph, you can select any 2. So if I select this as the first point, and say this one, because I'm looking for easy points. So this one example, a second point. So we have the first value on y-axis is y1. So this one is y1. And what is the value of y1 for us? This one is 0.52, 54, 56, 58, 0.6, 62, 64, 66. So y1 is 0.66. And what about y2? So 1.32, 1.34, 1.36, 1.38. So y2 is equals to 1.38. You have to show this on your graph, the lines which you draw. You have to show how you took these points. So representation, the drawing of these lines is also important. It's having marks. Not only getting the value of a gradient, but drawing or showing this on the graph is also having marks. Then the first point on x-axis is x1. So what is x1? This one is 0.424685, 0.5246 and 8. So x1 is 0.58. And what about x2? That is 1.2246 and 1.28. So that is 1.28. Now we'll use a formula for the gradient. The formula for gradient is y2 minus y1 over x2 minus x1. The y2 for us is 1.38, y1 is 0.66, x2 is 1.28, and x1 is 0.58. So 1.38 minus 0.66, that's equal to 0.72. And 1.28 minus 0.58, that is equivalent to 0.7. So 0.72 divided by 0.7, so it is approximately 1.02. So 1.02, always try to write your answer in 3 significant figure, 2 to 3 significant. So 1.02 is a gradient of this graph. So when we write here the gradient, that is 1.02. So 1.02 is a gradient, and then this gradient is numerically equal to, what does it mean, this statement? It means the value of the gradient is equal to value of the weight, or we can say the weight is equals to gradient. So if gradient is 1.02, what will be the weight? The weight is also 1.02. But what is the second mark? The second mark is a unit. Include a unit. So what is the unit of the weight? The SI unit of the weight is Newton. So 1.02 newtons. For these type of experiment, a student has assumed that the center of the mass of a meter rule is at 50 centimeter mark. Explain how you could find an accurately as possible the position of center of mass of a meter rule. No extra apparatus or material is available. So how we can find the center of the mass of a meter rule? Like example, if we have a meter rule and we want to find which position its center of the mass lie. So what we will do, we will pivot the meter rule at different positions. When the center of the mass and a pivot are in line, or the position where we pivot the meter rule is the center of the mass, if just above the meter rule, the pivot, then what will happen? The meter rule will be balanced. So how we can make sure that, or how we can identify the accurate position of a center of the mass? Because if the center of the mass and the pivot are not in the line, like if we pivot it from here and center of mass is on any other position, so this pivot will topple or it will rotate. If this meter rule will topple or it will rotate. Same thing, maybe a center of mass is here and we pivot from this point. So what will happen? The weight is acting downward. That will also cause a clockwise movement. So there will be a turning effect. But once the meter rule is pivoted at its center of the mass, so what will happen? It won't topple, it will be balanced. So practically, how we can find the accurate position of the center of mass of a meter rule? So we will repeat or pivot the meter rule from different positions. The position where it is balanced, that represent the center of the mass of the meter rule. Then briefly state the main difficulty. What is the main difficulty of this experiment? The main difficulty of this experiment is it is difficult to balance the meter rule when there is a load placed on it. Like it's impossible, like it's not possible, not impossible, but it is difficult to balance the meter rule when there is a weight is placed on it. Like when we place the weight, the meter rule might slip. So to overcome this difficulty, we have to just first estimate the position and then we place the weight. So what is the difficulty for this type of experiment? I have shared one file with you in which I mentioned all the difficulties related to the experiment. So this type of experiment, it is difficult to balance the weight, balancing the ruler or the meter rule when load is placed on it. So it's a difficult thing to balance a ruler or the scale when there is a load placed on the ruler. In question 2, a student investigates the resistance of a lamp. She uses a circuit as shown. She records the potential voltage V1 for a lamp and a current. So what are the values for V1? What is the value for V1 and I1? Use the screen annotation to complete the value for V1 and I1. V1 is 2.5. Yeah, that's right. It is, yeah, 2.45 or 2.5, but actually, yeah, it is right. But because we don't have the actually 2.45, why it is not correct? Because each box is representing 0.2. So if this is 2.2, this is 2.4, and this is 2.6. So it is between 2.4 and 2.6. That's why we say it is 2.5. and the other value is 0.3. If it was like if one of the marker was 2.4 and another marker was 2.5, then between them is 2.45. But as you can see, each line is representing 0.2, as there are 5 lines from 0 to 1. So each line is representing 0.2. So between 2.4 and 2.6, there will be 2.5. Then calculate the resistance. So you have this 2.5 and 0.3. What's the answer for resistance of the lamp? 2.5. Use the screen annotation to complete this. 2.5 divided by 0.3. 8.33. Better write your answer in 3 significant figures. So 8.3 is okay, but 8.33, the 3 significant figures we'll have. Then we have another lamp. A student connects lamp 2 in series with lamp 1, and he measured the voltage across both lamps, and he is finding the total resistance of the 2 lamps. So calculate the combined resistance of lamp 1 and lamp 2 by using a formula: voltage V2. This is the V2 and this one is I2. So V2 divided by I2, what's the answer? 2.4 divided by 0.21. What's the answer here? Use the screen annotation to complete. 2.4 divided by 0.21. So that is 11.4, and the unit ohm, that's right. So 11.4 is there. Okay, that's right. Next part, he connects lamp 3 and the resistance is 14.1. So a student suggests that R3 is 3 times R1. What was our R1? When we calculated the R1 was 8.33. This R1 which we calculated was 8.33. So student is suggesting that R3 is 3 times R1. So R3 is 3 times R1. R3 is 14.1, that is given here. 14.1 and 3 R1, 3 times R1. So R1 was 8.33. So 8.33 multiplied by 3, that is 24. That is 24.99. Statement, is it correct? The student statement matches with the result or no? So student statement does not matches with the result. As it does not match with the result, justification, you will mention this calculation part, what I did here. You will do this justification, you will mention R3, like 3 times R1 is not same as value of R3. Then complete a circuit diagram to show the 3 lamps connected in parallel, a voltmeter to measure the voltage across, and a variable resistor to control the current in the lamps. Use the screen annotation, draw the circuit. 3 lamps in parallel, a voltmeter. You can use the same diagram or you can draw on any side, like right or left or bottom or top of screen, you can also draw. Use the screen annotation to draw the circuit. 3 lamps in parallel first, a voltmeter to measure the voltage across them, and a variable resistor to change the current. So that's right. So first part is done. The 3 lamps are connected in parallel. Then you connect a voltmeter across the lamp. That's also correct. And there must be a variable resistor which changes the current in all the 3 lamps. Where we should connect, that's right, a variable resistor. And the circuit symbol for variable resistor, a rectangle with an arrow. So variable resistor arrow should be there, which shows that we can change the current or voltage. In question 3, a student investigate the cooling water. The thermometer in figure 3.1 shows a room temperature at the beginning of experiment. What is the value? What is the room temperature? Use screen annotation to complete this. What is the value of room temperature? Yes, 24, that's right. And always mention the unit, that is degree centigrade, not only the number with the unit as well. Then student pour 200 cm cube of a hot water into a beaker. He places a thermometer. He measures the temperature for theta. He immediately start the stopwatch and continue the temperature for every 60 seconds. Complete the time column in table. Complete this time column. What should be the values for the time column? Like student did this experiment with a 30 instead of 30-second interval, 60-second interval. Like after every 1 minute, student is measuring a temperature. So first one, the beginning is 0. Every 60 seconds. So what will be the number here? The next number. So first is 0, then it will be 60. That's right. The next one after another 60 seconds. So it will make the 60-second interval. Instead of 30, every 60. Yeah, so it will be 120. And then after, so 180 will be there, that's right. And 240. Then complete the column headings. The column heading means the units. So what should be the unit of time here and unit of temperature? Complete the column headings. So time is in second and temperature is in degree centigrade. That's right. Then calculate the decrease in temperature for first 120 seconds, and the last 120 seconds. So what we have to do, as we completed this is 0, 60, 120, 180, and 240. So for first 120 second, what is the temperature change? How much the temperature changes? What should you write here? So first it was 95, it turned into 85. So how much the temperature changes in the first? That is by 10. And what is the temperature change in the last 120 seconds? So last 120 seconds from 120 to 240. So from 85 to 78, so it becomes 7. So this is a 7 and this one is 10. So this is 7. So in the beginning, the temperature change was more and later the temperature change decreases. And that is obvious because initially the temperature is higher, so rate of cooling is faster. But as the temperature decreases, the rate of the cooling will also decrease. So tick the box tick the box to show your conclusion from the results in C. What you conclude from the results in C, the average rate of cooling is greater in the first than the average in the last. The average rate of cooling is less in the first, or average rate of cooling is same. So which one I should take? The first 120 seconds, it was changing a temperature by 10 degrees. The later 120 seconds, it was changing a temperature by only 7 degrees. So this was the first 120 and this one is the last 120. So which one I should take about the rate of a cooling? Is it same or in the beginning it is faster? That's right. The first box is correct, that average rate of a cooling, and justify by reference to the result. So you will mention the values, like in first 120 seconds, the temperature changes by 10, but the last 120 seconds, the temperature changes by 7. And rate of cooling always decreases with a decrease in temperature. Suggest 2 ways in which the student could reduce the rate of heat loss from a beaker in this type of experiment. Yes. So use a lid or use an insulation mat. That's good. So using a lid, using insulation mat cover can reduce the rate of heat loss. Draw a diagram of a measuring cylinder being used to determine the volume of a water and show clearly the level, and draw with a ruler a straight line showing the line of sight required to obtain accurate value of. Okay. So what we have to do, we have to draw a measuring cylinder here. So a measuring cylinder. This one is the base. Then whenever for a water we are reading, we read a lower meniscus, lower level. So there will be a meniscus, a curvature is there. And how we avoid a line of sight error? We should always look perpendicular, and we always focus on the lower or bottom of the meniscus. So using a ruler or the scale, you have to draw this. The straight line should be there. And there will be a marking, because one side it is having a marking. You don't have to write number. You just have to mark that. You should read from the side of the marking as well. So this is how we draw a diagram of a measuring cylinder in which we avoid a line of sight error, or we can say a parallax error. Then the last one, question 4, is